Hello my dear students, good afternoon. Welcome back for the next lecture. Now I am taking a subunit of electrostatics, that is electric potential, or you can say electrostatic potential. Before explaining electrostatic potential, I just want to derive some important relation, and that is the line integral of electrostatic field. Line integral of electrostatic field. And electric field is conservative, or you can say work done in moving a charge Q0 from one point to another in the electric field of Q. So this derivation is very important for explaining electric potential, and this derivation includes a lot of things. Line integral of electrostatic field. तो electrostatic field का line integral क्या होता है, उसका what is the answer? Electric field is conservative. Conservative का मतलब होता है कि those fields जैसे gravitational field, electric field, these are conservative fields. The work done by these fields, the work done by this moving a body in these fields from one point to another is independent of the nature of the path followed, but only depends upon the initial and the final points. So we will prove that the electric field is conservative in this derivation. And in this derivation we also derive the formula for work done in moving a charge Q0 from one point to another in the electric field of Q. And later on we will take the electric potential. So let us consider, this is a Cartesian coordinate system, and let us consider a source charge Q plus Q. Let us consider a source charge plus Q is kept at the origin. Now if it is kept here, so what will be the electric field? Electric field will be radially outwards. It is spherical symmetry. Charge यहाँ रखा है तो electric field कैसे होगी? Radially outwards होगी. Spherically symmetry. Let us consider 2 points A and B in the electric field of the source charge Q. These A and B points can be anywhere in the electric field of this charge, and this charge is fixed here. Now, what is the position vector of A? It is R, and let the position vector of B is R. So how much work is to be done in moving a charge from A to B? Now, for example, हम एक charge test charge लेते हैं. Unit positive test charge ले सकते हैं, or you simply a positive test charge. And you know positive test charge is denoted by a symbol Q0. तो मान लेते हैं चार्ज Q0 को यहाँ से कहीं से भी लेके आ सकते हैं. You can take any path. यहाँ से इधर जाए, डायरेक्ट भी आ सकते हैं, कैसे भी आ सकते हैं. We have to prove that in bringing a test charge from A to B along any arbitrary path is same. It doesn't depend upon the path followed. It only depends upon RA and RB, the initial and the final positions. So we will derive it. So what is OA? OA is the position vector of point A, which is RA. So what is OB? Position vector of point B, which is RB. हम क्या कर रहे हैं? एक टेस्ट चार्ज Q0 को यहाँ, फॉर एग्जाम्पल यहाँ पहुंच गया अभी. एक टेस्ट चार्ज Q0 को A से B की तरफ लेके आ रहा है. किसी भी रास्ते से ला सकते हैं, डायरेक्ट ला सकते हैं. तो आई एम टेकिंग एन आर्बिट्रेरी पाथ. तो हम क्या कर रहे हैं? यहां से यहां लाने के लिए वी हैव टू डू अ वर्क. तो बिफोर दैट लेट्स डिवाइड दिस होल पाथ इनटू स्मॉल लाइन एलिमेंट्स. छोटे छोटे टुकड़ों में इस पाथ को डिवाइड कर दो, एंड लेट द लेंथ ऑफ दैट line element is dl, and let us consider one such line element. Here it is P, here it is Q, P and Q. So let's consider very small line element PQ. यहाँ पे थोड़ा बड़ा दिखा रहे हैं, but it is not so big. कोई भी लाइन एलिमेंट PQ ले लेते हैं, which is very very small, whose length is dl. And for instance, जब वो पॉइंट चार्ज Q0 पॉइंट P पे है, तो उस पे फोर्स एक्सर्ट होगी. Who will exert a force? This, in the previous topics, I have explained you. Whenever you place a charge in the electric field of some other charge, it will experience a force, and that force is equals to QE. But here the charge is Q0, so it will experience a force, and that force is F equals to Q0 E. This is F equals to Q0 E, and what is the direction of this force? It is along the electric field. तो जैसे ही यहाँ चार्ज आएगा तो इलेक्ट्रिक फील्ड उस पे फोर्स एक्सर्ट करेगी, तो चार्ज विल मूव इन दैट साइड. बट वी हैव टू मूव द चार्ज फ्रॉम P to Q. इट विल बी डिफिकल्ट. अगर फोर्स उसको उस तरफ धक्का मार रही है तो उसको यहां से यहां लाना तो पॉसिबल नहीं है. उसके लिए हमें क्या करना पड़ेगा? उसके लिए हमें बाहर से कोई एक्सटर्नल एजेंसी से एक्सटर्नल फोर्स लगानी पड़ेगी, जो इस फोर्स को क्या करे? न्यूट्रलाइज करे, बैलेंस करे. एंड दैट फोर्स इज कॉल्ड एन एक्सटर्नल फोर्स, और उसका मैग्नीट्यूड इसके बराबर होना चाहिए और उसका डायरेक्शन इसके अपोजिट होनी चाहिए. To neutralize the effect of the force experienced by Q0 because of this charge, we have to put an external force. An external force direction किस तरफ होनी चाहिए? This direction. This is the direction of external force. This is the direction of the actual force produced by the electric field. Both are equal and opposite to each other. When these forces will balance each other, now it is easier to move the charge from P to Q, and it is without acceleration. When that force is zero, it means there is no acceleration along this direction or this side. It will not move here or there. So it is easier to move from P to Q. So what is the external force? External force, applied force is also called an external force. It is also called an applied force, because we are applying it from outside. I am using external force. What is external force? External force is equal and opposite to the force experienced by this charge because of the electric field. Sometimes we can write here EL. EL stands for the force experienced by the electric field. And here we can write EF, E external. Force because of the external source. But I am writing like this. This is the force produced because of the electric field, and this is the force produced by or provided by the external agency, just to neutralize this, so that the charge can be moved from P to Q without acceleration. So before I go to the next stage of this derivation, let me explain once again what we have to do. We have to prove these three things, and later on we have to go for electric potential also. And before going to electric potential, this derivation is very very important. क्या किया इसमें हमने? एक कार्टेशियन कोऑर्डिनेट सिस्टम लिया, उसके ओरिजिन में क्या रखा? एक सोर्स चार्ज रखा Q. इस सोर्स चार्ज के कारण क्या होगी? इलेक्ट्रिक फील्ड चारों तरफ होगी, स्फेरिकली सिमेट्रिक. हमें क्या करना है? हमें इनमें से कोई दो पॉइंट कंसीडर कर लेना इन इट्स इलेक्ट्रिक फील्ड, और एक टेस्ट चार्ज को A से B की तरफ लाना है without any acceleration and along any path. उसके लिए हमें काम करना पड़ेगा. क्यों? क्योंकि जब भी इसको यहां से यहां लाएंगे तो ये फोर्स, ये चार्ज उस पर फोर्स एक्सर्ट करेगा रेडियली आउटवर्ड्स. And to neutralize that force, we have to apply an external force just opposite to it, so that we can move the charge along the path, along the chosen path, any chosen path. तो P से Q लाने के लिए हमें कुछ वर्क करना है, एंड उसके लिए हमें एक्सटर्नल फोर्स अप्लाई करनी है. दिस इज द एक्सप्रेशन ऑफ एक्सटर्नल फोर्स, एंड दिस एक्सटर्नल फोर्स इज इक्वल इन मैग्नीट्यूड बट ऑपोजिट टू द फोर्स एक्सपीरियंस्ड बाय द चार्ज पार्टिकल F equals to Q0 E. अगर चार्ज पार्टिकल यहाँ होता तो ऑब्वियसली फोर्स कहाँ होती? इस साइड होती. एक्सटर्नल फोर्स कहाँ होती? इस साइड लगाते. यहाँ होता तो फोर्स कहाँ होती? इस साइड.
एक्सटर्नल फोर्स का मतलब इससे लगा था वी हैव टू न्यूट्रलाइज दिस फोर्स
और इसको न्यूट्रलाइज करने के लिए डेफिनेटली वी हैव टू डू सम वर्क एंड दैट वर्क इज टू बी डन बाय द सम एक्सटर्नल एजेंसी. Let's find the small amount of work done by the external force in carrying the test charge from point P to Q without acceleration. See, without acceleration. हम charge को यहाँ से यहाँ लेके जाना चाहते हैं, तो we have to do some work, and small amount of work done is given by the dot product of the external force and the displacement. तो हमने external force कौन सी लगाई है? ये displacement का है. This external force is applied just to neutralize it so that there is no acceleration. हाँ, बच्चे सोच रहे होंगे इस फोर्स को हमने इससे न्यूट्रलाइज कर दिया, तो how it is possible to move the charge from P to Q? Now since we want to move the charge from P to Q without acceleration, it means there is no need to put any force in this direction. And दूसरी बात, PQ is very small and we are moving the charge with a very small velocity or speed. It's slowly and slowly we are moving it, and for this movement PQ we don't need any force, or you need a negligible force for that. So therefore don't consider how it is moving from P to Q, or you can say it is because of the momentum gained earlier. So here we are concentrating over that. If this force is balanced by this force, and if this force is balanced by that, the net force is zero and there is no acceleration, and the work done by the external force is given by the dot product of external force and the displacement. This is the formula for the work done. Now put the value of external force. What was external force? मैंने यहाँ लिखी थी पहले. It was minus Q naught E. And it is dot T. This is a very important expression. Say this is 3. Now, students, this is a small amount of work done from P to Q. Now we have to find the total amount of work done from A to B. The total amount of work done in carrying a charge Q naught from A to B is obtained by integrating the above equation. See the abbreviations. Work done in moving a test charge from A to B. See, A to B is obtained by integrating the above equation. From where to where? इसको इंटीग्रेट कर दो. कहां से कहां? A से B की तरफ. We can take Q naught outside, integrate E dot dl from where to where? From A to B. See, what is this? This is the line integral of the electric field. तो ये भी हमने निकालना था. In the previous topic, यहाँ मैंने लिखा था वो. We have to find the line integral of the electric field. What is the work done? The work done from A to B is equals to minus Q naught, this one. Now see here. WAB upon, I'm moving it here, Q naught, and this is equals to minus line integral of electric field E TL. See, and this is from where to where? From A to B. This is a very important expression, very important expression. I will tell the importance of this expression later on. But what is this? This is the line integral of electric field, and this is work done in moving a test charge from A to B divided by Q naught. The work done per unit charge is called potential. I will explain in the next lecture. Work done per test charge or per unit charge is called potential. So we will do it later on. But at present, this expression is very important expression. आप इसे ध्यान में रखें. We will use it. थोड़ी देर में इसका हम यूज करेंगे. Now let's drive it further. work done upon Q naught is equals to minus A to B mod of E mod of dl cos theta, or you can write A minus A to B E dl cos theta. E dl cos theta. What is theta? Theta is the angle between E vector and dl vector. Where is E vector? This is E vector. Where is dl vector? This is angle theta. So once again see before I rub it, तो छोटा सा काम करना है हमने, यहां से यहां चार्ज ले जाने के लिए. That is small amount of work done and it is to be done by the external force dot d. This is the formula. Work done equals to applied force dot the displacement minus q naught e dot dl. Total work done from A to B integrate कर देंगे हम A से B minus q naught e dot dl, इसको integrate कर देंगे. Minus q naught is a constant. Take it out. A to B. Now take it down. WAB upon q naught minus E dot dl. This is a very important expression. Say this is equation number 3. It's very important. Now उसके बाद हम इसको solve कर रहे हैं. Dot product E dl cos theta. So what is dl cos theta? Let's see. What is dl cos theta? See this that figure. मैं थोड़ा बड़ा करके दिखाता हूँ. ये इलेक्ट्रिक फील्ड जा रही, ये dl वेक्टर, ये एंगल थीटा है. इस तरफ f इक्वल्स टू q नॉट e है, इस तरफ उतनी ही f एक्सटर्नल है, दैट इज माइनस q नॉट है. दिस इज एंगल थीटा. तो इसको रिजॉल्व करते हैं सही. तो ये कितना है, यहाँ से 90 डिग्री ड्रॉ करते हैं पहले. दिस इज 90 डिग्रीज, ये 90 डिग्रीज. If it is dl, this is theta, that side will be dl cos theta. And it is along the radius. This is r vector. What is the position vector of point P? R vector. So it is along the radius vector. This is to be called as dr. So हम dl cos theta को क्या कह रहे हैं? dr. So here dl cos theta को क्या करेंगे हम? dr कहेंगे. So what we have? We have work done AB upon Q naught, which is equals to minus from now E dr. Now unit vectors from RA to RB. Why? Because this integral is with respect to the position vectors. Therefore, it should be from RA to RB. Now let's put the value of electric. There is pure mathematics. What is the expression of electric field intensity at this point? इसका magnitude कितना होगा? इसका magnitude कितना होगा? It should be Q upon 4 pi epsilon naught R square. It should be Q with this Q, this one. इसके कारण यहाँ पे electric field का क्या strength है? उसका magnitude. It's Q 4 pi epsilon naught R square. And here, since Q is constant, 4 pi epsilon naught is constant, take it out. Minus q 4 pi epsilon naught 1 upon r square dr RA to RB. Minus q 4 pi epsilon naught. What is integral of 1 by r square? It is minus 1 by r. Minus 1 by r. RA to RB. जिन बच्चों को ये पता नहीं लग रहा है, तो there is a formula integral. X n dx equals to x n plus 1 divided by n plus 1. We can use this, we get this. Take minus outside. We get q 4 pi epsilon naught 1 upon r RA to RB. Put the limits now. Q 4 pi epsilon naught 1 upon RB minus 1 upon RA. Now see once again, what is dl cos theta? dl cos theta is dr. I have explained it. This is dl, this is theta. इसको इस तरह resolve करेंगे. This is dr. So dr, why it is called dr? Because it is along the radius vector. So dl cos theta is called dr. This is dr. This vector, it's not a vector, it's a scalar quantity now. यहाँ vector था, dot dot. Now we are not putting any dot. Because we have used the value of dl cos theta as dr. E की value put कर दो. What is the electric field intensity here? Take the constant outside. 1 by r square. What is the integral of 1 by r square? It's minus 1 by r. Put the upper limit minus the lower limit. So what's the final expression now? What is the final expression? See what we got now. So what we got? Work done from A to B upon Q naught is equals to Q upon 4 pi epsilon naught 1 upon RB minus 1 upon R. This is very important relation. अगर हमें work done चाहिए, what is this called? I will tell you. This is called electric potential. I will take this later on. But today I am taking line integral of the electric field and work done in moving a charge from A to B. So what is work done in moving a charge from A to B? Work done in moving a charge from A to B is equals to minus Q naught line integral of electric field E dot dl, जिसको बाद में सॉल्व करने के बाद हमारा आंसर क्या निकला? इसको यहां भेजेंगे Q naught upon 4 pi epsilon naught 1 upon RB minus 1 upon R. This is the work done in moving test charge from any arbitrary point A to B whose position vectors are RA and RB. This is work done. Now, if I want to prove that electric field is conservative, if, now let's play with this formula. Let's play with this formula, this one, and this one. Let's first of all take this. If RA is equals to RB, कहने का मतलब this is point A, this is point B, यहाँ से यहाँ गया, यहाँ से फिर वापस यहाँ. If RA equals to RB, what will we get? Work done कितना मिलेगा हमें? Q upon Q naught 4 pi epsilon naught 1 upon RA minus 1 upon RA. That means work done is 0. Means if the initial and the final points are equal, so there is no need to do or same. If the initial and the final points are same, the work done is 0. This work done is 0. This work done is 0. Or you can say mathematically you can write like this. If the initial and the final positions are the same, the work done AB is 0. I mean to say line integral of electric field over a closed path. See here, closed. Why closed? Because the position, initial position and the final position is the same. Is 0. If it is 0, it means electric field is conservative. Electric field is conservative. Why? The electric field over a closed path. See, it is closed. Why it is closed? See, this is the condition. If R equals to RB. If R equals to RB, the path is closed. यहाँ से शुरू किया, वापस वहीं चले. Work done कितना है? 0. अगर work done 0 आएगा तो with the help of this derivation, this formula, electric field is 0. They prove that electric field is conservative. So one can also prove from here also. Since the work done depends only on initial point and the final point, not on the path. Not on the length of the path, not on the nature of the path, but only depends upon the initial and the final points. This work done only depends upon initial and final point. This proves that electric field is conservative. But mathematically, this is better. If the path is closed, the initial and the final positions are the same. We have proved that electric field is work done is 0. And if work done is 0, with the help of this formula, the line integral of electric field is 0 over a closed path. So we have done 3 topics today. First, the line integral of electric field. This is the line integral of electric field. What is the line integral of electric field? If I want to write, I am writing here. Here, see, line integral of electric field from say point A to point B is equals to work done from A to B upon Q naught. Now, negative sign, either you could put a negative sign here or there. There is no problem. It is better to put here. If I want to derive the line integral of electric field, this is the line integral of electric field. The first one. The second one is prove the electric field is conservative. We have proved it. Third one is what is the work done in moving a test charge from point A to point B. This is the work done. So it is advised that the students may learn, keep all these 3 formulas 1, 2 and 3 in your mind for studying electric, potential and for doing numericals. That's all for today. Thank you. Thank you very much.